a high-speed MPU. Some of these make the little tink sound at boot, and some do not. First thing you notice is the display is 100% functional. We are in attract mode, and the lamps are doing their thing, attracting. So this board had some corrosion damage, alkaline corrosion, from a leaky battery some time ago. And the client stated that, while it had corrosion, that some of the displays were not working correctly, missing segments, and impossible to tell what it is reading. It's been around since the 1990s and sat in a basement for about 10 years, and it's time to get it resurrected. So what did I find? Well, there's a janky connector down here in the lower left. It's one of those craptastic original Williams 3 through 7 connectors, so I replaced that. That really wasn't a problem, and even this rather horrid looking repair, that tip 102, is not a problem. So in a situation like this, I'm going to leave that. It works. The only thing I can do is make it look better, but it's going to require putting additional heat on the solder joints and the pads, and I don't really need to do that. The corrosion had destroyed most of the reset section. In here you can scrape that entire reset section, leaving a few components. There's a 1K, a 4.7, and a 10K resistor here. I added a jumper where the 5817 diode is. You need an actual diode if you have a battery pack, but since I've installed NVRAM, we don't need that diode. Replace these 3 capacitors. These are the 5, 12, and minus 12 filter caps. A couple of caps up in the sound section, and these 2 also are in the sound section. The traces, I didn't think I had to rebuild any of them. It just had to clean up the corrosion. The connector to the soundboard was really kind of corroded, so I got rid of it and replaced it with a dual row single SIPs. And also had to replace the 6821 because it was corroded. Now normally, if you have, this is just a tip, if you have corrosion in this area, you always need to socket the 6821. Crime is rampant these days, and sometimes this one also, because if you don't, and you have to run jumpers from U41 up to these SIPs or the headers, then you're going to have to remove that chip anyway. So it's better to put a socket in there just from the get-go. Special solenoid section of this board is really clean, which is nice. These things, I've seen a lot of holes burnt in this section of the board. And the lamp matrix is clean too. Of course, I washed this board after I installed the modern reset generator as described in the pin wiki. I cleaned up this board, and this has been conformal coated. So there is no more bare copper in this area. You can't see it on camera, but that's all conformal coated. So let's put it into test. I love high speed. Using my universal display test panel, built by our friend in the Pacific Northwest, Mr. Victor, aka Dumbass. And the displays are working perfectly. Of course, a Steve Ritchie classic, a kind of the story that he tells about some of his driving in the Los Angeles area, as I recall. Lamp matrix is working fine. Let's test some solenoids. High Speed was the first System 11 game. We refer to it as System 11N or Nothing MPU. And it did not multiplex the solenoid drives, so that's why it'll go through the first 16, and now it's into the special solenoids. And the 2 orange ones are the flipper ground enable. I can test these solenoids with switch inputs also, and they are all working properly. Switch levels, I'll do switch edges, and the last switch on high speed is switch 52. That's 110. I'm going across the diagonal until I get past 52. There's 46 and 52, so we are good to go. I'm going to cycle through the audits and adjustments. I've already set it to free play. That's setting 23. And we'll complete our cycle through those. The MPU reboots with a 0 on the 7-segment display, which looks really nice with conformal coating on it. And this MPU board is good to go. Thank you so much. I look forward to seeing how this works out when you put it into a game that's been sitting for 10 years. And thanks again for sending it.